Hi everybody. I want to start working my way towards logistic regression, and logistic regression does involve probability. So I want to just talk about that a little bit, but I should also talk about odds and log odds, because all three are important in understanding logistic regression. So let's go over here to probability, and the probability of an event is just a measure of its likelihood of occurring. So just for some context, maybe we're thinking about the likelihood that a particular team will win a particular game. So if it's not likely, we would say that the probability is close to 0. If it's very, very likely, we would say that the probability is close to 1. If it's a 50-50 chance, we would say that the probability is a half. So basically this interval from 0 to 1, right, probabilities are numbers between 0 and 1. So when you're down close to 0, the event is not likely to happen. When you're at 0.5, 50-50 chance. And when you're at 1, it's pretty much certain to happen. But that's not the only way to measure the likelihood of an event. Another way is to use what are called the odds. So the odds are calculated by taking the ratio of this red segment, which is the probability, and the blue segment, which is what's left over in this interval. So you just take that fraction. So if the event is not likely, once again, the odds are going to be close to 0 because the length of that red segment is very, very small. For a 50-50 chance, the probability would be 0.5, but the odds would be 1 because the red and the blue line are identical and their ratio would be 1. When we move towards the event being more and more likely, the odds get very, very, very large because we're making a fraction here and dividing by a smaller and smaller number. So basically the odds go to infinity for an event that is certain to happen. And then finally, log odds are important as well. And log odds is just the logarithm of the odds. It doesn't matter which logarithm you use. I'm using the natural log in all of this. So when you're down here close to 0, right, that logarithm will be like at negative infinity, right? So for an event that's not likely, log odds, negative infinity. As we bring the likelihood of the event up, let's say to a 50-50 chance, then we're at 0 with the log odds. And then as we go towards certainty, plus infinity. So it's just kind of like you're using different intervals. Probability, 0 to 1. Odds, 0 to plus infinity. Log odds, negative infinity to plus infinity. So for an event that is unlikely, 0, 0, negative infinity. For an event that is like a 50-50 chance, 0.5, 1, and 0. And then finally for an event that's pretty much certain, 1, plus infinity, and plus infinity. So I just have another way of looking at it down here, looking at odds and log odds. So what I have here is I have the probability along the x-axis here. And I'm plotting the odds here and the log odds here. So when we're close to 0, odds is also at 0, but log odds is at negative infinity. If we go to 0.5, all right, we go up to 1 with the odds, and it's kind of like you're right in the middle, right, with log odds at 0. And then they both fly off to infinity when you have an event that is pretty much certain to happen. But here you can actually see the shape of the odds curve and the log odds. So anyway, that's what they are, and so we'll use them to try to understand what logistic regression is. And so I'll get into that next.